Hey class, welcome to our slides for lesson 6.3. We're going to work through these together. It's not a huge lesson, but it does have some great new pieces of math that we're going to learn about. It's called exponential functions. So on your notebooks, you're going to graph all four of these, and then you're going to sketch all four of them in your notes. Once you have all four of them sketched, make sure you label them so you know which one's which. But then, what do you notice about them? Like, is there anything different about these types of lines that you're seeing? We've seen lines like this before, y equals 2x plus 4 and y equals 1/2 x plus 2. But now we see these, ones with exponents of x values. A little different. Make sure you write down what you notice about them, and then put that in Canvas too. Our learning target for today is evaluating exponential functions and graphing them. There are some ideas of real-life problems, but truthfully, we probably aren't going to get to that, so I shouldn't have included that here. Alright, so we are going to identify our new type of function. So up to this point, in all of middle school, 7th, 8th, 9th grade math, we've been hitting what's called linear functions, so y equals mx plus b. Now we're hitting a new type called exponential functions. These are of the form ax, or a times b raised to the x. And what this means is that our a value is our y-intercept, and our b value is our multiplier. So make sure you write all that down. So a value is y-intercept, b value is a multiplier. So the a value tells you where it starts. You'll notice on one of our graphs from our warm-up was 4 times 2 to the second. That means we start at 4 and it's doubling each time. This is called a exponential growth factor, because it would be doubling as we move through. If we made a table for this, our table would look like 0, 1, 2, 3, and it would start at 4, and then it would double each time. So this would go 8, 16, 32. So this is the idea of exponential growth. It looks like a graph like this. It's a curve going upward. Y-intercept, multiplier, example of a table. But we also have this other one where you could be decreasing, and this is what we call, and I'll use a different color for this one, this is called exponential decay. And this is where, again, our starting value, but we'll notice this time, every time our multiplier is 1/2, so it's actually going to get smaller. So if we start with the same idea, we would start with an x and y table, and this goes like 0, 2, at 1 it would be 1, at 2 it would be 0.5, and at 3 it would be 0.25. So this is a lot to write down. I know you don't need to write down as much here, but you should write down the core topic, and that this is the exponential function, and that there are things called exponential growth and things that are called exponential decay. Notice how the multiplier, if it's more than 1, it's going to grow, and if it's less than 1 but more than 0, it's going to decay. Here we're just going to identify are these exponential functions or linear functions. So as we look through this, our x values change by 1, and our y values here are all adding by 2. This makes it linear, as it's an adding by 2. It's an adding function, and it's adding the same amount. It's constant. For our b value, or for our b question, again, our x values are increasing by 1, which is good, but our y values are doubling. So this one's actually times 2, times 2, times 2. So this one is exponential. Because it's doubling. So obviously a big part of math is computing things. So when you compute things, remember you can use a decimal calculator, but when we compute these ones, we are going to want to identify and plug things in. So at this point, If it says evaluate for the function, we simply change the x values for whatever it is given. For the first one, we would change this to y equals negative 2 times 5 raised to the third power. You can plug this in on Desmos, or you could work it through step by step. If you choose to work it through step by step, you would get negative 2 times 125, which would then, our y value here would be negative 250, meaning the input of 3 gives you an output of 250. It's a very fast change. Our other one, an exponential decay, again, let's identify this one over here. This one here is growth, because the b value is more than 1. This one here is decay, because that b value was less than 1. As we plug in values here, we would simply do the same idea. 3 times 0.5 raised to the negative 2. Earlier in this unit, we went over negative exponents, so that shouldn't be weird to you. So as we work this one through, we would get 3 times 4. 3 times 4 is 12. So our y value would be 12, meaning our input at negative 2, our output would be a positive 12. I've talked about this a few times, but if the b value is greater than 1, it's going to be increasing. And it's going to be increasing, getting further and further away from the x-axis as it goes up. A value is positive, it's going to go look like this. If the a value is negative for some reason, it would look like this. When the b value is less than 1, so think of like decimals and fractions, it's going to get closer to 0 because you're multiplying it by something that gets closer and closer to 0. This here, I want you guys to go on Desmos and get the practice of graphing a equation that looks like the following. So go ahead and graph y equals 3 times 3 raised to the x. Once you have that on Desmos, sketch a graph on your notes. Likewise, go on Desmos and graph the following one, which has a fractional exponent to it. So let's go y equals 10 raised to the, or times 7 over 10 raised to the x power. Okay, I want you to practice graphing this so you can see what types of things occur. Remember, this one is decay. Our previous one was a growth feature. There are more things to exponentials, but we're not going to hit them this year. You will re-hit them in Algebra 2. Good luck with your homework. It's a lot of computations and a lot of graphs. Remember to use Desmos as you work through it.